All right, let's jump right in. We're about to crack open the ICSE Class 10 Chemistry Specimen Paper for 2026. And if you're here, you're probably aiming for that perfect 100, right? Well, you're in the right spot. We're not just going to go through the answers. No, we're going to build the strategy, the mindset you need to absolutely ace this thing.
So how do you turn a 2-hour exam into a perfect score? That's the big question, isn't it? And look, the secret isn't just memorizing formulas. It's about having a rock-solid game plan for the exam itself. How to handle the clock, how to give those laser-focused answers under pressure, you get the idea. Okay, let's get into it.
So here's how we're going to tackle this. First, we'll decode the paper and talk time management. Then we'll hit Section A hard. First the MCQs, then the short answers. After that, it's all about strategy for Section B. And then we'll wrap it all up with a final blueprint for that perfect score.
First up, let's decode this paper. You know, acing this exam starts way before you even put pen to paper. How you use your 120 minutes is every bit as important as the chemistry knowledge you got stored up in your brain. Okay, check this out. This table is your roadmap. And that first 15 minutes of reading time, that is pure gold. Don't just skim through the pages. This is where you become a strategist. You're picking your battles for Section B before the clock even really starts. Trust me, making that choice early on is a huge weight off your shoulders. If you can stick to this kind of schedule, you'll have some breathing room at the end to double-check everything.
All right, let's talk Section A, starting with those multiple choice questions. Think of these first 15 marks as quick wins. They're designed to test your core concepts, so the name of the game here is speed and accuracy. Let's look at a couple of examples. Okay, first MCQ. This is a classic question. It's basically asking you, hey, do you know the difference between an acid, a base, and a salt? They want you to find the one that isn't an acid or a base. So the key here is to spot the salt. Let's use a little process of elimination, shall we? KOH, that's a base. Dilute HCl, classic strong acid. CH3COOH, that's a weak acid. The only one left standing is NaCl, sodium chloride. And why? Because it's a salt. It splits into Na plus and Cl minus ions, no hydronium, no hydroxyl. Boom! That's a super easy mark if you've got your definitions on lock.
All right, here's another great one. It's testing a really specific chemical property. They're basically looking for a metal oxide that's a bit of a fence sitter. It can act like an acid and a base. Does that ring a bell?
Yep, we're talking about amphoteric oxides. This is one of those concepts you just have to know. The two big ones to remember are aluminum oxide and zinc oxide. They react with both acids and alkalis. Just lock those two into your memory, and you've got yourself an easy mark every time. The mole concept. I know this topic can make some people a little nervous, but seriously, don't panic. It's just a set of logical steps. Let's walk through it together right now.
See? When you break it down, it's pretty straightforward. Step 1. You calculate the moles for each gas. 22 grams of CO2 is half a mole. 10 grams of H2 is 5 moles. Step 2 is remembering Avogadro's law, which is a lifesaver here. It just means the volume ratio is the same as the mole ratio. So we've got a ratio of 0.5 to 5. Simplify that, and you get 1 to 10. Done.
All right, let's move on to the other part of Section A, the short answers. Your mantra here is concise but complete. You're not writing an essay. Just give the examiner exactly what they're asking for. Let's take a look at an organic chemistry question.
So here's a classic two-parter. They want you to give some IUPAC names and then draw a structure. For questions like these, precision is absolutely everything, especially when it comes to the numbering. Let's see what a perfect answer looks like.
Now, this is where the details really matter. Look closely. It's not just propanol, it's propan-1-ol. Not just pentene, it's pent-1-ene. That little number is everything. It tells the person marking your paper that you know exactly where that functional group is. This isn't just being picky. This is the stuff that separates a great score from a perfect one.
Okay, let's talk about Section B. This is where 40 marks are on the table, and you get to choose 4 out of 6 questions to answer. This choice is probably the biggest strategic move you'll make in the whole exam. Seriously, don't mess this up. Picking the wrong questions can really cost you.
This right here is your battle plan for Section B. Don't just jump on the first question that looks easy. Take a moment, scan all 6. Figure out which ones are from your strongest chapters. And here's the crucial part. Make sure you can answer every single subpart of the questions you choose. A question isn't easy unless you can nail all of it. Get this choice right, and you're already halfway to a great score in this section. Okay, so let's imagine we've picked our questions, and we've decided to tackle question 6, part 3. This is a total classic stoichiometry problem. If you just follow the steps, this kind of question is basically a gift, guaranteed full marks.
So this is what we're looking at. They give us a balanced equation, a starting mass, and then ask for 3 different things. It might look like a lot, but it's really just a 3-step process where each answer flows right into the next one.
Okay, let's just walk through this step by step. First, we find the moles of our reactant. 126 grams, divide by the molar mass, and we get exactly 0.5 moles. Simple enough. Now, the best part? The mole ratio in the equation is 1-to-1 across the board, easiest ratio ever. So that means we're going to make 0.5 moles of chromic oxide and 0.5 moles of nitrogen. All that's left is to convert those moles into what the question asks for, mass for the oxide and volume for the nitrogen. See how it's just a chain reaction? One step leads right to the next. Lay your work out like this, nice and clear, and you literally can't lose those marks.
And there we have it. We've pretty much taken this entire paper apart. So what are the big takeaways? What's the final blueprint for nailing that perfect 100? This is it. This is your final checklist. There are no magic tricks here. It's just about being disciplined. Manage your time like a hawk. Know your definitions backwards and forwards. Show every single step in your calculations. Use those specific scientific keywords. And finally, practice. Practice with past papers until this whole strategy just becomes second nature.
And that pretty much wraps up our breakdown of the paper. You've got the strategy now, but the real work, well, that starts with you. So I'll leave you with this question. What's the one chapter or concept we talked about today that you're going to go and master first? Pick one, own it, and start building that confidence. You've got this. Good luck.